Okay, pre-calculus, we're going to start Unit 3 today. And the first part of Unit 3, we're going to be working with polynomials. In fact, we'll be doing that for the first 3 lessons. And then we end the lesson with rational functions. So what we're going to start off with are polynomials, what they are, what they look like, things like that, what we can predict by looking at the equation. These are all going to be higher degrees, so we're looking at degree higher than 2. All right. As you write down notes about polynomials, there's some key things you need to know. First of all, polynomials are always continuous. So that means they won't have any breaks, holes, or gaps. You can basically trace it without lifting your pencil. So know that about a polynomial, they're always continuous. Okay, so we had some examples of piecewise functions on that worksheet over 2.5 that showed that a lot of those graphs were not continuous. So this is an example of a graph that is not continuous, and it says functions with graphs that are not continuous are not polynomials. Polynomials also have smooth, rounded turns. So there's not going to be anything linear about them. Or sharp. They're all going to be rounded, smooth turns. An absolute value graph is not considered a polynomial graph because it has a sharp turn. In calculus, we talk about polynomials, and then we talk about those functions that have sharp turns. Absolute value is not a polynomial. It has a sharp turn. All right. One of the key things about this lesson is that we're going to put all kinds of things together to graph these. And so we're going to be looking at point plotting, intercepts, maybe some symmetry, maybe not. We'll be doing sketches by hand. And it's good to know what the end behavior of these graphs will be. So we're going to be comparing them to x to the n. N's going to be an integer. It's either going to be even or odd. And so we'll start here with looking at when that exponent is even. So you see y equals x squared is the light gray function. That's the parent function you guys know from our second unit. You'll see that x to the fourth has the same general shape. The same U shape is there. But it flattens out a lot here at 0. So it gets really flat. Now, it's not constant. What's happening is those values that get really close to, as your x gets really close to 0, your y's there get extremely close to 0, but they're not equal to 0. So it says when n is even, the graph of y equals x to the n touches the x-axis at the x-intercept. However, when n is odd, the graph will cross the x-axis at the x-intercept. So I always tell students to remember that if an exponent is even, it's either going to be 2 arms up or 2 arms down, just like x squared would be. And if the exponent is odd, it's always going to be left arm down, right arm up, just like x to the third would be. So they have those characteristics in common. And it does say here, the greater the value of your exponent, the flatter the graph is near 0, 0. Okay. So what we're going to do here is just practice graphing a couple of these. Not anything major. You can use an XY table, but we can also kind of get by without doing these. These are going to be sketches. So 0 to the 5th is 0. -1 to the 5th is -1, but this has a negative out front, so that's going to be a 1. And 1 would be -1. Now 2 is going to be like -32. So you can see that it's going to grow really quickly. But I'm just going to plot those basic points. So this is like a reflection of x to the third, except when I get here close to 0, what I'm going to try to do is flatten that out and then turn it. So you're going to try to flatten it out right there, kind of at 0. I did an okay job with that, but all right, for this one, it's going to mimic x to the second. So it's basically going to look like a parabola, but it will be flatter at the vertex. It's going to be shifted left 1, just like if it were x squared, it would be to the left 1. And you can do more points if you want. If you do 0, you're going to have 1. And if you do -2, you're going to have -1 to the 4th, which is 1. And again, when I sketch this, I'm going to try to just really flatten it out here at my intercept. So that's kind of what we're looking at for these sketches. Just flatter either x-intercept there or as you pass through the x-axis. All right, the leading coefficient test. That's going to tell us a lot about our graph. We're going to be looking at the function's degree. Is it even or odd? And is that leading coefficient, which we'll call A, is it positive or negative? All right, so I have 4 graphs for you. We're going to be looking right here at this term on our polynomials. So we want to know if when A is greater than 0, when A is positive, and when A is negative, and A is positive, A is negative. All right, so we're also going to look at N is odd, and then N is odd again, and then we have even degree. So basically, when our degree is odd, it's going to mimic x to the 3rd. When A is positive, that means it's going to look just like x to the 3rd on the end. So it'd be left arm down, right arm up. And anything could happen here in the middle. It doesn't matter what's going on in the middle. What's important is that you have left arm down, right arm up. And then for if N is odd and A is negative, that just means my arms flip. Left arm up, right arm down. Again, it's these ends that are super important. All right, when A is positive and our degree is even, then it's going to look like x squared, so it's going to be both arms up. Now the middle again could be doing anything, but the ends are both up, and when A is negative, my ends are both down. So you can again just do about anything in between, but the 2 arms are going to be going down. So what's important here are what the ends are doing. Okay. All right. So for example 2, we're just going to describe the right hand and left hand behavior of the graph of each function. So I see a negative and I see x to the 3rd. So normal x to the 3rd is left arm down, right arm up. So that's going to switch to left arm up, right arm down. So I would say increases on left, decreases on right. This is x to the 4th. It's positive, so it's just going to be like x squared, so both arms up. So I'm going to say increases on left and right. And then x to the 5th is just like x to the 3rd. Left arm down, right arm up. So decreases left, increases right. Okay, and then we've got some practice problems there for you to play with. Okay, what I need you to do next is just stop and copy down this part right here. And this is where we're going to start our notes on Thursday. What you need to do for the rest of the class period. I have the keys posted on Canvas for the practice problems for 2-7, for the worksheet over 2-7, and for the worksheet from lesson 2-5. All of those can be found on Canvas under modules under those particular lesson numbers. You need to go back through all of those submissions, look at them in your notebook, and grade them with the key. Make corrections as needed. You do not need to resubmit anything. Just go back through and make sure you look at the keys and correct your mistakes. You also need to finish up your Delta Math assignment, because that is your test review for the big test that you have tomorrow. All right, I'll see you guys back in class then.